Okay, so we have fractions, and we're doing operations with the fractions here. It looks like right here I've got a variable in h that's being multiplied by 3/4. So 3/4 times something is going to equal 11/12. So let's look at how to do this. It's what we're going to need to do is whenever we have a variable that has an operation being done to it, in this case multiplication, we just have to do the opposite operation in order to isolate the variable and get it by itself. If you take a number such as h and you multiply it by 3/4, well, in turn you can just divide it by 3/4, and that will get you right back to h. So I'm going to bring my equal sign down, and I'm going to show that 3/4 divided by 3/4, and I'm going to go ahead and do my keep change flip. It will be times 4/3, and I'm going to cancel ahead of time that and that and that and that. Ones all around. I will end up with 1 over 1, and we just write 1h as h. On the other side, dividing by 3/4 will actually get me my answer. So let me get some of this out of the way here. I am going to have 11/12. And again, my variable is being multiplied by 3/4, so I will divide by 3/4. So this will be 11/12. And again, divided by 3/4, I have to do times 4/3. This is my keep. This is my change. This is my flip. This problem will simplify a little bit ahead of time. 12 and 4 are both divisible by 4. So let me just show that I'm going to simplify both of these. 4 will go into 4 once. 4 will go into 12 3 times. Multiplying fractions, we multiply straight across the top and straight across the bottom. 11 times 1 is 11. 3 times 3 is 9. Now, if I had 9 out of 9 pieces, I would have 1 whole. But I've got 2 extra 9ths up here, 9, 10, 11. So I do have 1 whole within this fraction here. This is an improper fraction. But I have 2 9ths left over. My answer is going to be 1 and 2 9ths. That's how that looks with a fraction. I wanted to show real quick what it looks like with the decimal. Just pull all this out of the way. And so let's pull this decimal up here. Now, in this scenario, my variable is being multiplied by 36 hundredths. So this is just all about opposite operations. I will divide by 36 hundredths. In order to maintain my equality on both sides of the equal sign, I must also divide this side by 36 hundredths. I'm going to bring my equal sign straight down and put my answers to these two problems here. On this side, when you take a number, in this case y, we don't know what the number is, but if we multiply it by 0.36 and divide it by 0.36, those are opposite operations that cancel each other out, leaving that variable by itself, which is the whole goal here. We want to know what y equals. We can do that because we can multiply 0.36 on both sides of the equal sign and maintain our equality. This division right here, the 18, will fall down into the house, so what we do right here whenever we have a decimal out here is we move it twice to the right to get it behind the 6 here, so this will be a 36. But I also have to move the decimal twice here, so I'm just going to fill in with those 2 zeros. In order to solve this problem, I will be putting 36 into 1800. Now 36 won't go into 1, it won't go into 18, it won't even go, it won't go into 18, but it will go into 180. So a little trick that I use, I say, well, I've got a 3 here, how many times will 3 go into 18? And 3 will go into 18 6 times. So I give it a try with 6. 6 times 6 is 36. Carry my 3. 6 times 3 will be 18. It's going to be too much there. So I'm going to back it out a little bit, which is no problem. So now 36 into 180. Let's try, that was 6 times. Let's go 5 times. 5 times 6 is 30. 0, carry the 3. 5 times 3 is 15. 16, 17, 18. Ah, it goes into it evenly. That's nice. When I subtract it out, I get 0. And normally what we do is we drop this 0 here, but it's going to be nothing down here. 36 will go into 0 times. I do have to fill in the 0 because my decimal point is here now. And then our decimal point's right there, but we don't need it. In this problem, this is our answer. Y equals 50.